Hello and welcome back to the course on deep natural language processing. In today's tutorial, we're going to look at how the sequence-to-sequence models are trained. We've already talked about the architecture, and so this is what we've come up with, that this is our architecture. We've got an encoder, a decoder, which resemble two recurrent neural networks. Our inputs are fed in, and then once we have our inputs here, then what happens is the decoder starts decoding the values, and then we're feeding in the values back into the decoder as they're being decoded. Now, the difference between training and actually applying is that in this case, this is the end result. This is what we want, that after our network has been trained, once we feed in the sentence, hello Kirill, checking if you're back in Oz, once we feed in the sentence, then we get this as an output. Yes, I'm back, end of sentence. Now this is the end result. Now we're going to look at training. So for training, we're going to look at a different sentence. We're just going to take one of the sentences from a different, we'll take a different email, and in this case, we will already have the full response that was provided in that case. So this is how it works. The email was, did you like that recipe I sent you last week? And the actual response that, for instance, in this case, I sent, like this is hypothetical, this never happened, but if I had sent the response, it would have been, yes, it was great, end of sentence, hypothetically. So if it was a good recipe. So here we've got, did you like that, and so on and so on. So that recipe that I sent you last week, end of sentence. So that's our inputs to the model. That's our encoder part. And then for the decoder, we already know this. So the difference why I highlighted this in red is because we didn't know this and the model generated this. In the training part, we actually know the end result, and now that will allow us to train the model, and that's what we're going to look at now. So here you can see that there's a lot more letters, there's a lot more happening. So here we've got U's, we've got W's, we've got U2s, W2s, and V's. And so in different literature, you might find different notations. We're just going to stick with this one. And basically, those represent the parameters of our network, such as weights, such as the weights of the neural network that we need to update. So basically, we need to update these parameters throughout our training in order for the network to learn from the training data, and how, what does that imply? That's the main question we're going to answer. So we're not going to go into the detail on the mathematics or on what weights are where, what these parameters mean, and so on. The main key is we want to get the intuition behind things. We want to understand, what does that exactly mean? And so there are two main points that we're going to look at. First one, the main one, is what that question means. What does it mean that the network is going to be learning? Well, let's look at it. So once we fed in this sentence or this email, which says, did you like that recipe that I sent you last week, end of sentence, then the network, through training, what's going to happen in an iterative process is going to look at the different options that it can spit out. So for instance, it will start learning, okay, what word can I specify? We know the correct first word is yes. But the network actually has 20,000 different options to pick from, 20,000 different words. And so through the process of backpropagation, this network, this sequence-to-sequence model, is going to make sure that the probability of getting the word yes is the highest. So it's going to update the weights and the parameters of the network in such a way that when the word yes comes up, it will have the highest probability so that indeed it is yes. Then what happens next is it moves on to the next word. This part of the network is considered done, and then now, given that the output here is yes, and this information is passed on over here, this information is passed on between this segment of the network and this segment, and we're feeding back the value yes into our layer of neurons. Now we want the output to be it. This, we know that this is the final output that has to be on place number 2. So the network, given that this is the input and given that the first word is already yes, is going to aim to maximize the chances of, or the probability that it, or the like, is going to maximize the probability of the word it for place number 2. So it's going to update itself. It's going to, like, through the process of stochastic gradient descent and backpropagation, it's like, oh, this error is going to be backpropagated through network. It's going to update itself in order to maximize the score that is assigned to the word it in this place out of 20,000 words. Once that is done, it will move on and it will do the same thing for the third place. Given that we have that input, the first word is yes, the second word is it will maximize, it won't even worry about these for now, it will maximize the score that is assigned to the word was. So again, backpropagation and so on. And this is, we just look at one example. As you know, in neural networks, there's going to be like tons of training data. So it's going through them. It's like going through every one of them. There's multiple epochs, many epochs. It's all happening like in a very iterative process, and the network is adjusting itself to match all the inputs and outputs. And so therefore, like, it looks very simple, but in reality these are all layers of neurons, and it can actually have even more levels, so it can be a deeper network, as we saw before. And so because it's not that simple, there is room for it to adjust its weights to accommodate all different options of input emails and output answers that were sent. And so the goal for the network is to make sure that it can model the logic and behavior that was observed in the email. So that, like, it looks at an email, it understands the meaning behind it, and then it creates a response, and that should be in line with all the training data it has. So that's how it goes, like one by one, goes through these. The second important thing that we need to observe here is that the weights. So a natural question that you might have is, okay, so we've trained up this network for, I don't know, let's say in this case we have a question of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 words, including a question mark plus the EOS symbol, 12. And so 12 here, and then 1, 2, 3, 4, 5 on the output. And so this is kind of like the question. This question is related to the fact that we have variable input length and variable output length. What if, so this looks like a very specific network, 12, 5. What if we had 20 and what if we have 20 here, and then and the response that the network generates is going to be like 3 words. So how is it? It's not ready for that, right? It feels like it's only trained up to work with 12 and 5. How can it work with variable? Like, how can it even explore options? Like, it can explore emails that have a different length to anything it's seen before, and responses that might have a different length to anything it's seen before. The answer is yes. And the reason for that is, as you can see, the weights, they're actually the same. As you go through the network, as you go through, like if you add on more parts to the network, like if you add on another, like if you have more than 12 here, if you add on or remove, what will happen is just like it replicates itself. Every element here has the same parameters. U1, W1 here, U2, W2. And the output you have V's. So basically every time, like even if you add more, if more, like say if it didn't come up with end of sentence here, it just kept going, you'd add more and more and more. So that basically means like whatever is trained during the training process, you'll have all these parameters, and then so you'll have U1, W1, U2, W2, V, and then basically those are going to be the foundations of this sequence to sequence model. and regardless of how big it is, like big or small, it's just going to be recreated. We would have a problem if every time you add a new segment, like it has its own weights, it has its own parameters. But in this case, because it's replicated, we don't care about that. That means that these weights are going to be trained through the normal process of backpropagation, stochastic gradient descent, and then regardless of how long, so however long they are, we're training the same thing. However long the output is going to be using those values or those weights that we trained up. So there we go. That's how the sequence-to-sequence network is trained. Very similar to any sort of backpropagation, just the standard backpropagation and stochastic gradient descent that we know about. And the only concepts, the new concepts are that you've got the variable and the variable inputs and outputs, and that is already taken into account. So all we had to have a look at is how does it actually take into consideration the different responses that we have to the different emails. So there you go. I hope you enjoyed today's tutorial, and I look forward to seeing you next time. Until then, enjoy deep natural language processing.